and then 3a plus 2b minus 5c, and then minus 3a plus 8b minus 5c, then minus 3a plus 2b plus c. I'm going to show that these 4 points are coplanar. So as I explained, to prove that any 4 points are coplanar, first we must convert them into 3 vectors. So what are the 3 vectors here? So first take the points as A, that is OA. OA is equal to minus A plus 4B minus 3C. And then B. B is OB is equal to 3A plus 2B minus 5C. And then C is equal to OC is equal to minus 3A plus 8B minus 5C. Minus 8 minus 3a plus 8b minus 5c. B is OD is equal to minus 3a plus 2b plus sc. These are the 4 points. Now we'll convert them to vectors. AB vector is equal to OB minus OA. So just subtract OB minus OA. So that is 4a, and then this minus this, so minus 2b, and then minus 2c. Next you find AC. Convert them into 3 vectors AB, AC, AD. AC is OC minus OA. So C minus A, this minus this. So it is minus 2A plus 4B minus 2C. Next is AD. AD is equal to OD minus OA. OD minus OA. Subtract. Then it is minus 2A minus 2B and then plus 4C. Like this we get. Now what you do is, you will assume that one vector is a linear combination of the other two, XAC plus YAD. This is the procedure to prove that the 4 points are coplanar. First convert them to vectors and then they take this condition. AB, what is AB? 4A minus 2B minus 2C is equal to X into AC. AC is minus 2A plus 4B minus 2C plus Y into AD. AD is this vector. So minus 2A minus 2B plus 4C. Now when you simplify it is, A coefficients are minus 2X minus 2Y. This is into A. Here A and here A combine. Group the terms. Next it is 4x minus 2y into B plus again minus 2x plus 4y into C. So you get like this. Now since A, B, C are non-coplanar, you can equate the coefficients. Since A, B, C are non-coplanar, you can equate the coefficient. So minus 2x minus 2y is equal to 4, and then B coefficient 4x minus 2y is equal to minus 2. Next third one, minus 2x plus 4y is equal to minus 2. Now number these as 1, 2 and 3. Now take any 2 equations and solve. Any 2 equations. We'll take 1 and 2. So we'll solve 1 and 2. So solving only 2 equations you should take. Solving 1 and 2 we get, so you have minus 2x minus 2y is equal to 4, and then 4x minus 2y is equal to minus 2. So when you subtract minus and this is plus, you get minus 6x. These two will get cancelled. So minus 6x is equal to 6. So x is equal to 6 by minus 6, that is minus 1. Now substituting 1. Substituting x is equal to minus 1 in the first equation, we get x is minus 1. So minus 2 into minus 1 minus 2y is equal to 4. So that means minus 2y is equal to 4 minus 2, that is 2. So you are getting y as equal to 2 by minus 2 is equal to minus 1. So you got x as minus 1 and y also as minus 1. Now what you have to do is you must substitute in the third equation. Substituting x is equal to minus 1, y is equal to minus 1 in third equation we get minus 2 into minus 1 plus 4 into minus 1. What is it? 2 minus 4, that is minus 2. That means it is satisfied. The third equation is, equation 3 is satisfied. Equation 3 satisfies x is equal to minus 1 and y is equal to minus 1. So that means all the three equations have unique solution. They have unique solution. If the third equation is not satisfied, then it means that the three equations have no solution. They are coplanar. The A, B, A, C, AD are coplanar. A, B, A, C and AD are coplanar. So they are coplanar. So these vectors include the points. So the points A, B, C, D are coplanar. The points A, B, C, D are coplanar. So like this we do the problem. So this type of problems are very important, and in the next chapter, product of vectors, you learn different methods, another method to show that the points are coplanar. So this is one method. So we'll use the basic principle. We'll find out, you are given 4 points, convert them to 3 vectors like this, and then take one vector as the linear combination of the other 2 vectors like this. Equate the coefficients of like vectors on both sides. Take any 2 equations, don't take all the 3. Take any 2 equations, solve them completely, find x, y, substitute in the third equation. If the third equation is satisfied, then they are coplanar. They have unique solution. So the 4 vectors are coplanar. So the 4 points are coplanar. If the third equation is not satisfied, then they are non-coplanar. That is the procedure. Okay, next problem. Next, again, this problem is very important for 4 marks. Write down if the points. So if the points whose position vectors are 3i minus 2j minus k, and then 2i plus 3j minus 4k, and then minus I plus j plus 2k, and 4i plus 5j plus lambda k are coplanar. So he has already given that the 4 points are coplanar. Then show that lambda is equal to minus 146 by 17. This is the problem. So again the procedure is the same. You will convert them to 3 vectors, and again you will solve 2 equations in the same manner, and then substitute in the third equation which contains lambda, and then find out lambda. That is the procedure. So method is almost the same. You will solve 2 equations, substitute in the third equation to find lambda. So point, let OA is equal to first point, that is 3i minus 2j minus k, and B is equal to the second point, 2i plus 3j minus 4k, and C is the point minus I plus j plus 2k, and D is the point OD is equal to 4i plus 5j plus lambda k. Now you convert them into 3 vectors. So AB vector, AB is equal to OB minus OA. OB minus OA. This minus this I am writing directly. So minus I plus 5j minus 3k. and then AB. Next AC. AC is equal to OC minus OA. See that the initial point is same. AB, AC, AD like that. AO, AC, OC minus OA. This minus this. So minus 4I plus 3J plus 3K. Okay, next AD. AD is equal to OD minus OA. So this minus this. So 4 minus 3, 1. And then 5 plus 2, 7. And then here it is lambda k plus k. So we'll write lambda plus 1 into k. Like this we'll write. Now A, B, C, D, these points are coplanar. So we'll first take the linear combination. AB is equal to x times AC plus y times AD. So AB is minus I plus 5J minus 3K is equal to x into AC. So x into minus 4I plus 3J plus 3K, and then plus y into AD vector will write. So I plus 7J plus lambda plus 1 into K. Like this will do. Now since equate take the common thing, so minus 4x plus y into I, and then plus 3x plus 7y into j, and then plus 3x plus y into lambda plus 1 into k. So you will get like this. When you group the terms, you get like this. So minus I plus 5j minus 3k. Now since I, j, k are non-coplanar, I, j, k are non-coplanar, you can equate the coefficients of like vectors. That is minus 4x plus y is equal to minus 1, and then 3x plus 7y is equal to 5, and then 3x plus y into lambda plus 1 is equal to minus 3. So like in the earlier problem, number them as 3 equations like this. Then solving 1 and 2. So solving 1 and 2, we get, so minus 4x plus y is equal to minus 1, and then 3x plus 7y is equal to 5. So we'll multiply this equation by 7 and subtract. So when you multiply, it is minus 28x plus 7y is equal to minus 7. This will write as it is, 7y is equal to 5. Now we'll subtract minus minus minus. So this will get cancelled. 31x is equal to 11. So we'll get x is equal to minus 12 by 31. X is equal to 12 by 31. We are solving this x value we got as 12 by 31. So we'll substitute this x value in the first equation. We should solve only 1 and 2. We should not touch the third one. So we'll substitute in the first equation. From this you'll get y as equal to 4x plus 1. So 4x minus 1. So we'll substitute in this x value 12 into 4, 48 by 31. So when you take LCM simplify, you'll get like this. So these are x and y values. Now you are given that the points A, B, C, D are coplanar. So that means the vectors are coplanar. So these values of x and y should satisfy the third equation. So since they are coplanar, these values should satisfy the third equation. So we are substituting in the third equation. What is the third equation? 3x plus y into lambda plus 1 is equal to minus 3. We'll take this 3x to that side. So it is minus 3x. So now we will substitute x value and also y value. So you will get like this. After taking LCM, you can cancel 31 and take 17 to the denominator here. Simplify, so it is minus 129 by 17. Now take this 1 also to that side, LCM, simplify. You will get the value of lambda as minus 146 by 17. Hence it is proved. So like this we do the problem. This problem is very okay. Next problem. Next problem. Uh, Next it is third problem. If A B C if A plus B plus C, A plus B plus C is equal to alpha D, and then B plus C plus D is equal to beta A, and A, B, C are non-coplanar vectors. A, B, C are non-coplanar vectors. Non-coplanar vectors. Then show that A plus B plus C plus D is equal to 0. So this is the problem. So we are given only about A, B and C. So what we'll do is, from the given equations you write, combine them and write in terms of only A, B and C. So you are given like this and also B plus C plus D is equal to beta A. Now from this equation, first equation or second equation, you take D value. So from second equation we will get D value as beta A minus B minus C. Now we'll substitute this D value in first equation. So you will get A plus B plus C is equal to alpha into beta A minus B minus C. So that means alpha beta A minus alpha B minus alpha C. So you are getting A plus B plus C is equal to like this. Now you are given that A, B, C are non-coplanar. Only A, B, C are non-coplanar. So you can equate the coefficients of like vectors. Since A, B, C are non-coplanar, you equate the coefficients. A coefficient is 1. 1 is equal to alpha beta. B coefficient is 1. 1. It is like 1 into A, 1 into B, 1 into C. So 1 is equal to minus alpha. 1 is equal to minus alpha again. So alpha is equal to minus 1. When you substitute alpha as minus 1 here, beta is also equal to minus 1. Now substitute either alpha or beta in any one of the equations, you will get the required solution. So substituting in first equation, we get this A plus B plus C is equal to alpha D. Alpha is minus 1. So minus 1 into D. Bring all this to this side. So you will be proving that A plus B plus C plus D is equal to 0. So A plus B plus C plus D is equal to 0. Hence it is true. So like this we do the problem. Now in this chapter you have vector equations of line, vector equation of plane, and then some problems based on that. That is the next topic in this chapter. Now we'll write some. You can try these problems. Now that the ABC first problem, A, B, C are non-coplanar. Prove that the points. These are the points. 4 points are given. 6A plus 2B minus C, and then 2A minus B plus 3C, and then minus A plus 2B minus 4C, then 12A minus B minus 3C. So show that the 4 points are coplanar. So we solved similar problems, same procedure, convert them to vectors, take them as A, B, C, D, convert them to vectors A, B, A, C, A, D, then take A, B as x times AC plus y times AD, and then equate the coefficients of like vectors. If the third equation is solve any two equations, if the third equation is satisfied, they are coplanar. So here they are coplanar. The third equation will be satisfied. Now if I, j, k are unit vectors, we know I, j, k vectors along the positive directions of the question is given like this. Along the positive directions of the coordinate axis. Then show that the 4 points, then show that the 4 points are, the points are 4i plus 5j plus k, and then minus j minus k, and then 3i plus 9j plus 4k, and then minus 4i plus 4j plus 4k are coplanar. Same, instead of A, B, C, you have I, J, K. So it is the same procedure. I can take down another problem. 2 points P and Q have position vectors as OP is equal to 3A minus 2B. OQ is equal to A plus B. The question is, find the position vector of the point R. Position vector of the point R which divides the line joining PQ. Which divides, okay, we'll write PQ in the ratio 2:1. In the ratio 2:1, first bit is internally and then second bit is externally. So you have like this PQ. Solution PQ you have. So R is the point which divides in the ratio 2:1. In the ratio 2:1. So you know MB plus NA by M plus N. And then for externally it is MB minus NA by M plus N. So for this the answer is, 5A by 3 and then 4B minus A. So you can try these problems. In the next period, we'll discuss about the vector equation of line, plane, and then some problems. These problems, we'll just discuss about these vector equations of line and plane. And we'll continue this in the next period also. So till we have time. Next one is vector equations of a line, of a straight line. In this we have two equations. So first one is, you have suppose that the straight line is passing through a point A and it is parallel to some vector B. It can be in any die, parallel to the vector B. Then the equation of the vector equation of the line, the vector equation of the straight line passing through the point A, and parallel to the vector B. So the line is parallel to the vector B and parallel to the vector B is R is equal to A plus TB, where T is a scalar, T is a real number. You must by heart this equation. R is equal to A plus TB, passing through the point A and parallel to the vector B. So here B is a vector, A is a point. R is the variable vector. Like see, suppose in the coordinate plane, suppose you have to write the equation of any straight line like this. So you will write the equation as some 4x plus 3y minus 2 is equal to 0, something like this will write. So here x and y are variables. xy is a variable point, any point on the line. In the same way, here also r is a variable point. R is any point on the line. Like how xy is any point on the straight line, here you will have r. R is a variable point on the straight line. It can be any point. Next is vector equation of a line passing through 2 points A and B. So by heart these equations. The vector equation of the straight line, passing through the points, small a bar and small b bar, passing through the points A and B is R is equal to 1 minus t into A plus tb, where t is some real number. You can as R is equal to A plus t into B minus A. So you can write either this form or this form. In some problems, we need this form, A plus t into B minus A. In some problems, we can directly use this. So this is all about the vector equations of a straight line. By heart these two. So we'll continue in the next period. R is equal to 1 minus t into A plus tb, or you can write the same equation, you can write as A plus t into B minus A. T is a scalar. So this is about the vector equation of a line passing through 2 points. Now suppose that one point is origin. The vector equation of the line passing through origin and the point A. So if one point is origin, then this becomes 0. So the equation becomes R is equal to TB. Origin and the point A is R is equal to TB. You substitute origin. A is origin here. So you can write in this, if you substitute A as 0, you'll get R is equal to TB. R is equal to A. A point, if you take TA, so R is equal to TA, because one point is here. Passing through the origin and the point A is R is equal to. So the vector equation of the line passing through the origin and the point. So one point is origin. So substitute. Another point is A. So R is equal to T. In the next step, we'll continue with the problems. Vector equations of plane problems. With that, we'll complete this chapter.
Hello students, I am Sambamurthy, lecturer in botany, Government Junior College for Girls, West Maradpalli, Secunderabad. Today, I would like to discuss something about inflorescence, part of